reduction of Boolean expression in a SOP form by using a K-map. So, in the yesterday class, already we learned about the fourth step of the reduction of Boolean expression in a SOP form by using a K-map. That fourth steps are, the first one is draw the K-map for the given function. What are the functions they are given? First, we have to draw the empty K-map for the given function. If that function is a 2 variable or a 3 variable, we have to go through a 2 variable K-map and 3 variable K-map. So if the given function is a 4 variable, we have to draw the 4 variable K-map for the given function. The second step is map that function. Map that function by entering the ones for which the output is 1 in a corresponding square. The third step is after inserting a ones in a corresponding square, entering the zeros for the rest of the squares. The fourth step is after inserting ones and 0, we have to encircling all the adjacent ones to make a pair quotient octets. In the yesterday class, we learned about how to make a pair quotient octets, and also we learned about how to reduce the Boolean expression in the pair quotient octets. So yesterday, as I told, after making this pair quotient octets, certain another things are to be taken care before arriving at a final expression. So that is, the first one is map rolling. First one is map rolling. The second one is overlapping group. Overlapping group. The third one is redundant group. After making this pair quotient octet, we have to concentrate on this map rolling, overlapping and redundant group. So now in this class, let me learn how to rolling the map and how to do the overlapping and how to remove the redundant group in a given expression. So the first one is map rolling. In this map rolling means rolling the map. The map rolling means rolling the map. While rolling the map, the top edges touches to bottom edges and the left edges touches to right edges. In the map rolling, opposite edges are to be square and the corner squares are contiguous. So, while making this pair quotient octets, map must be a roll in a given function. So, this map rolling means rolling the map. While rolling the map, top edges are touches to bottom and the right edges are touches to left. So, let us consider one example to understanding how the map must be a rolling. The example of map rolling is 0, 2, 8, 3, 10 and 11. So, this is a given function. So, now let us see how the map is rolling on this given function. The first, we have to draw the K-map. This is a 4 variable K-map. Here W, X, Y, Z. Here W bar, X bar, W bar X, W X and W X bar. Here Y bar, Z bar, Y bar, Z, Y, Z and Y into Z bar. The numbering scheme is 0, 1, 2, 3, 4, 5, 7, 6, 12, 13, 15, 14, 8, 9, 10 and 11. So this is the 4 variable K-map and this is about the numbering scheme. So after drawing the table, now we have to map the function by inserting a ones for the given input output is a 1 in the corresponding square. Here they are given 0, 2, 8, 3, 10 and 11. So inserting a 1 in the given square for this given function. So here they are given 0, 0. So in here inserting a 1 in the square m0, and here they are given 2. So inserting 1 in a m2. Similarly 8, 3, 10 and 11. So after entering the ones in a corresponding square, the third step is entering 0 for the remaining the square. So here it is 0, 0, 0, 0, 0, 0, 0, 0, 0 and 0. So after inserting ones and 0, the fourth step is encircling the adjacent one to make a pair towards octets. So here in the given map, here the two adjacent ones are encircled. It makes one pair. Similarly, here two adjacent ones are encircled. It is also formed the pair 1 and pair 2. But here in the case, only the one variable is encircling. Here also only the one variable is encircling. So now after encircling, now let us see how to reduce the expression. In the given map, only the one variable is encircling. In the one variable group, there is no possibilities of reduction of the variables, reduction of expressions. So here, in the one variable group, there is no possibilities of a reduction of a variable. In this case, the map must be a roll. When the map must be rolled, here this map is rolling when the map is rolling, this top edges which is touches to bottom edges, when these both group are combined to forming one pair. That is, the pair 1 is m0 plus m8. Here the only one variable. In this case, there is no reduction of a expression. So in this case, we have to must roll the map. When map is rolling, this top edges touches to bottom edges, then it both are combined to form one pair, that is m0 plus m8. So in this m0 and m8, it's called as pair 1. Therefore, the reduced expression for this pair 1 is reduced expression for this pair 1 is the m0 value is w bar, x bar, y bar and z bar, plus here the m8 is w, x bar, y bar and z bar. In the given function, here x bar, y bar, z bar is both are the common in the both the terms. So take it out, then we get w bar plus w. According to a complementary law, the x plus x bar is equal to 1. The variables are adding with its complements, then we get the 1 value. So here x bar, y bar, z bar into 1, then we get x bar, y bar, z bar. This is the reduced expression for given pair 1. So now in the given map, already again we got a two pair. This is pair 1 and pair 2. We can take it as pair 2 and pair 3 because already we considered it as a pair 1. In the given pair 2 and pair 3, according to a pair reduction rule, in the pair only the one variable changes its stage from complemented to uncomplemented. So only the one variable is removed. In this case, let us check. We have to check if there is any possibilities for making a quads or octets by rolling the map. In this case, let me have to check if there is any possibilities for making a quads or octets by rolling the map. So here, if we are rolling the map, these both, when the top edges touches to bottom edges, then these two pairs are combined to form one quads. So here, this pair 2 plus pair 3, these two pairs are combining. While we rolling the map, this top part touches to bottom when these both the pairs are combined to form one quads. So that is one is M3 plus M2 plus M10 plus M11. Because why we have to rolling the map means in the pair reduction there is the possibilities of reducing only a one variable. But if we are going to give the preference to a quads, here we have to chance to reducing the two variables. So by rolling the map, here we got one quads. In this quads, two variables are removed. That is, in the first pair, here when it is moving horizontally, this x changes, this z changes in states from non-uncomplemented to complemented. So here z is removed. When the map is rolling, when it is moving vertically, here the axis changes in states from uncomplemented to complemented. So x is removed. Here x is removed, then we get only y and w. So therefore the reduced expression for this quad is w and y. Here in the given quads, while it is moving horizontally, only the z is changes in states from uncomplemented to complemented form. So it is removed. Only the remaining thing is only y. So when it is moving, while rolling the map, when it is moving vertically, when only the axis changes to its states from uncomplemented to complemented. So only the remaining reduced expression is w. So finally we got the reduced expression for this quad is w and y. Therefore the total reduced expression for this given function is the first pair we got x bar, y bar and z bar plus the quad value is w and y. So this is the reduced expression. This is reduced Boolean expression in a SOP form. SOP form, reduced Boolean expression. So this is about map rolling. In the map rolling, while rolling the map, all the edges are touches to each other. And the top edges touches to bottom and the left edges touches to right. So this is about map. So while making this pair Watson octets, the map must be a rolling. So now the second thing is overlapping. The second thing is overlapping. The second one is overlapping. Overlapping means same ones are encircled more than once. Overlapping means the same ones are encircled more than once. So here the overlapping means the same ones are encircled more than once. So now let us consider one example to understanding this overlapping. So the example is the given function 1, 3, 5, 6 and 7. So this is a given example. So now draw the K map for this function. This is a 4 variable K map, that is w, x, y, z. Here w bar x bar, w bar x, w x, w x bar. Here y bar z bar, y bar z, y z, y and z bar. Numbering scheme is 0, 1, 3, 2, 4, 5, 7, 6, 12, 13, 15, 14, 8, 9, 11 and 10. So now after drawing the map, inserting ones for which the output is 1. Here they are given 1, so inserting 1. Here they are given 3, so inserting 1 in the M3. They are given 5, 6 and 7. So here after inserting the ones, you have to inserting 0 for the remaining strings. So now after inserting the zeros and ones, we have to make a pair quartz octet. To making a pair quartz octets, we go through a encircling adjacent ones. So here in the given map, while mapping the while encircling the adjacent ones, first we have to concentrate on the octet group, because in the octet group more number of groups are reducing the more variables. In the octet group 3 variables are removed, but in the given map there is no possibilities for the octets. So now let's move on to a quartz. So here the 4 adjacent ones are encircled in forming a one quartz. So here only the one variable is remaining. See here if the possibilities of encircling this one is overlapping with this group, then it form a pair. Here in the given map we got a one pair and we got one quartz. So the pair is M7 plus M6, and here the quad is M1 plus M3 plus M5 plus M7. So here this one which is encircling more than once, hence it is called overlapping. It is called overlapping group. So now here we got one pair and quartz. The reduced expression for this pair is, here in the given pair the Z is changes its states from uncomplemented to complemented. So this Z is removed. So the only the remaining thing is Y. So here we got a W bar and X. So this is the reduced expression for this pair. So now let us move on to the quad. In the given quad, this is a quad. Here while moving horizontally, Y is changes its states from Y complemented to Y. So Y is removed. The remaining thing is Z. Here the Y is removed because it changes its states from uncomplemented to complemented. So Z is removed. When it is moving vertically, here X is changes its states from complemented to uncomplemented form. So here the X is removed. The remaining thing is only W bar. In the given quartz, while it is moving horizontally, the Y changes its state, so it is removed. The remaining thing is Z. When it is moving vertically, the X changes its state, so it is removed. The remaining thing is W. So this is the reduced expression for the given quartz. So therefore, the reduced expression for the given function is reduced expression for the given function is the pair. From the pair we got a Y W bar X plus from the quartz we got the reduced expression is W and Z and W bar. So this is the reduced soft form Boolean expression by using the K-map. So this is about overlapping. In the overlapping means the same ones are encircled more than once. In the given example, these ones are encircled with both the group, which is encircled more than once, hence it is called overlapping group. Here we got one pair and quartz. In the pair, only the one variable is removed because it changes its states, that is Z. So remaining got Y, and here the same thing is W bar and X. So this is the reduced expression for the pair. From in the quartz, the reduced expression is while moving vertically, only Y removed because it changes its states. While moving vertically, horizontally Y is removed, vertically X is removed because it both changes its state. So this is the reduced expression for the quartz. The total reduced expression for the given function is, one is we got from the pair, we got the reduced expression is W Y W bar X, and from the quartz W Z and W bar. So this is the reduced expression for the given function. This is about the overlapping group. So third one is redundant group. redundant group is a group in which all the ones are marked by another group. That is pair, quarts and octets. In the redundant group is a group in which all the ones are marked by the another group. That is a pair, quarts and octets. So now let us consider one example, then we will get a understanding. The example is 0, 4, 5, 13 and 15. So this is a given function. So now drawing a K-map. This is a 4 variable. One is W bar X bar, W bar X, W X, W and X bar, Y bar Z bar, Y bar Z, Y Z, Y and Z bar. The numbering scheme is 0, 1, 2, 3, 4, 5, 7, 6, 12, 13, 15 and 14, 8, 9, 11 and 10. So here, now inserting the ones for which the output is 1. Here they are given 0, so inserting 1. Here they are given 4, so inserting 1, 5, 13 and 15. So after inserting the ones, inserting 0 for the rest of the square. So after inserting zeros and ones, now we have to encircle the adjacent ones to make a pair, quarts, octets. So here in the first group, the two adjacent ones are encircled. It form a pair 1. Again, this one is overlapped with the another group. Then again we get a pair 2. So here this one is again overlapped with the another group. Is form a pair 3 and pair. This is a pair 1, pair 2, pair 3. Here this one is overlapped with this one. Then it is form a pair 4. In the given function, we got a 4 pair. Here the redundant group says one is a group in which all the ones are encircled or overlapped with the another group. That is here this one is overlapped with this pair and this one is overlapped with this pair and this one is overlapped with this pair. Here this one is overlapped with this pair. So totally we got a 4 pair. So here the pair 2, pair 3 and pair 4. In the pair 2 and pair 3, these both are redundant group because its ones are overlapped with the another group. In the pair 1, pair 2, pair 3, pair 4, this pair 2 and this pair 3 are considered as a redundant group because its ones are overlapped with the another group. So this pair 2 and pair 3 both are removed. So then we got only a 2 pairs, that is pair 1 and pair 4. Therefore, the reduced expression for the pair 1 is in the given pair 1, y bar z is the same. Here, x is changes its states. Here, this x is changes its states from complemented to uncomplemented. So, it is removed. Here, we got only w bar. So, the reduced expression for this pair 1 is y bar, z bar and w bar. Similarly, the reduced expression for this pair 4 is here this w, x are the common. Here the y bar z into yz. Here the y changes its state, so y is removed. Only we got a z. So this is the reduced expression for pair 1 and this is the reduced expression for this pair 2. Therefore, the reduced expression for this given function is y bar, z bar, w bar plus y, x and z. Here in the redundant group, it's a group. In the the remaining group we got is P1 and P4. The reduced expression for the P1 is wxz and the reduced expression for the P4 is wx and z. The P1 is y bar, z bar and w bar. So total reduced expression for this given function is y bar, z bar, w bar plus wx and z. So this is about the redundant group. So now let us move on to these steps. What are the steps are to be followed to solving the reduction of the soft form Boolean expression by using the K-map. Here the fifth step is after the fourth step, encircling adjacent ones to make a pair ones and octets. The fifth step is map rolling. The fifth step is map rolling and overlapping. Map rolling and overlapping. The sixth step is removes the redundant group if we get any redundant group, then it is removed. The seventh step is finally brightly reduced expression. Brightly reduced expression for the given function. So, reduced expression for the given function. These are all the steps are to be followed to reduce the Boolean expression in the soft form by using the K-map. So, I hope you all guys are understood this session. I will stop here. So, in the next class, let me solve the problems by using the K-map as to be followed in this step. Thank you all.